1, 0.
1, 2, 3, 4.
Hi, Pre-Calc 12. Today we're going to do 6.2 Trigonometric Functions of Acute Angles. So today we're going to look at sine, cosine, and tan, but you're going to get introduced to 3 other functions that are not on your calculator and you may have not known up until today that also exist. So we're going to take a look at that in the next couple minutes. Okay, so to get started right now, let's have a review, and this is definitely a review. We're going to go way back to Math 10, where we learned about SOHCAHTOA. And when we did SOHCAHTOA, we learned the acronym of this was to help us quickly remember that sine is equal to opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. So here you have a right angle triangle. Here's angle theta right there, and going opposite will be over here. Next door is adjacent, and then up top, the side that's farthest away from a right angle and the longest side is going to be our hypotenuse right there. Okay, so if we take a look at here, we want to come up with a little snapshot to be able to summarize this. We know that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tan is going to be opposite over adjacent. Now, there are 3 additional functions, and let's spell them out for us first. So we're going to learn about something here called cosecant, CSC right there, secant, and cotangent. Okay, now these are the reciprocals, I call them the cousins sometimes, of sine, cosine, and tan. So if sine's reciprocal is cosecant and sine is so opposite over hypotenuse, then cosecant is going to be, you got it right, hypotenuse over opposite. Secant, if is related to cosine. So if cosine is adjacent over hypotenuse, then secant is going to be hypotenuse over adjacent. And cotan is the reciprocal of tan, so we're going to have that to be adjacent over opposite. And we'll look at a couple examples here where we're actually able to use cosecant, secant, and cotangent for that. There is no fancy acronym for it or anything like that. We don't have another SOHCAHTOA. I mean, if you wanted to, I guess you could say it's cosecant is hypotenuse over opposite, secant is hypotenuse over adjacent, and cotan is adjacent over opposite. But I don't think you're going to hear too many people say cho sha cow too often. So, so we'll just stick with the reciprocals of sine, cosine, and tan. Okay, now we want to understand if you do want a couple memory tricks in terms of trying to figure out, well, how do you know which one pairs up with which? I know that tan is going to pair up with cotan. I think that's the easiest one for sure. As silly as it sounds, the S pairs up with the C. So the opposite letter. So if that's a C right there, it's going to pair up with an S. Okay, if you want another kind of funny way of trying to remember something, if this is sine theta right here and it pairs up with cosecant, you could always say it can't be cos. All right. Okay, so regardless of how you remember that, those are our 3 reciprocal functions, and we're going to use them in a couple of our upcoming examples. Okay, so the first thing is, how would you express this, and how would you express this in a calculator? So secant pairs up with cosine, and we do know that cosine is adjacent over hypotenuse, but if we're told that they're the reciprocal trig ratios, another way of being able to express that would be to say secant is equal to 1 over cosine. Okay, that's the reciprocal right there. And we could do that for each of these two here, which is 1 over sine. My left hand's really coming into play here right there. 1 over sine, and then right here, this is going to be 1 over tan. Okay, why is that useful to us? It's useful to us because if we want to enter these into the calculator, as we mentioned at the start, your TI-84 does not have a secant, cosecant, or cotangent button. So you need to be able to evaluate something like this without being able to press a secant button or cosecant button or cotangent button. Okay, so first thing we want to recognize with this first example is that example A is being measured in radians. And that means that you're going to need to be in radian mode. So check your mode right now on your calculator. You can't do this question without a calculator. And you can do that by pressing the mode button. And if you take out your calculator right there, that's right to the right of the second button. And you'll scroll down and you'll see you're either in radians or you're in degrees. So for this first example, you're going to have to be in radians, and then you're going to have to switch it back. And I know that's a little frustrating, but for part B and part C, you're going to have to make sure that you are in degrees. Okay, so looking back at the example above right here, secant of 4.38, if secant of theta is equal to 1 over cosine theta, then secant of 4.38 would be equal to 1 over cosine of 4.38. And that's what you're going to enter into your calculator right now. So in your calculator, you're going to say 1 divided by cosine 4.38. And you're going to press enter, and you should get an answer of negative 3.0646. Okay, 4 decimal places. If you got something else, then check to make sure that you are in the right mode. And let's try these next two examples here. So this is going to be 1 over sine 65 and 1 over tan 295. Okay, so switch back to degree mode. And in degree mode, you'll enter those in. And you're going to get something like 1.1034. And this one here is going to be negative 0.4663. So make sure that's something that you've actually gone through and done. Don't just wait for the answer there. Make sure you can enter that into your calculator just fine. Okay, this is a review from Pre-Calc 11 part right here, but what we want to do is we want to make sure we understand what's happening in each of the different quadrants as we go around our circle. So right here we have quadrant 1, 2, 3, and 4. And what I'm going to do is I'm going to draw, sometimes I call this a bow tie. So what that means is we're going to go, okay, here is an angle in quadrant 1, and if we want to create a right angle triangle around a unit circle, remember that you always take your point on the circle and you drop it perpendicular down to the x-axis, and you can do that for each of the 4 quadrants where you always take it, drop it perpendicular to the x-axis. And what you've done is you've created something that somewhat resembles a bow tie. We'll remember what a reference angle is. So we have something right here, 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 and here. Each of those are reference angles. That's the angle between the terminal arm and the x-axis. So O is the angle that's closest to the origin. And we use that as a basis to be able to find out what our ratios are for each of our triangles, depending on whichever quadrant we're in. And what I want to list right here is where we have positive and negative values. And this should seem as some sort of a review from last year, but it's super important that we go over this again. So what we'll say is in quadrant 1, everything's going to be positive. If we move to the right, this right here is a positive direction. If we move up, that's a positive direction. And the hypotenuse, the radius, that's always going to be positive because that's going to represent the distance right there. In quadrant 2, we would say, well, if I'm going to the left, so now I'm heading into a negative x territory, that's going to be a negative right there. My y value is still going to be positive, and like we said, the hypotenuse or the radius will always end up being positive. In quadrant 3, this is going to be a negative, it's positive, and right here, that's a negative, and that's positive. Okay, so what you want to do here is in quadrant 1, you can see that all sides are positive. So we're actually going to say something along the lines of they're all positive. But in quadrant 2, that's not the case. If you take your reference angle and you perform the sine operation, sine being so, opposite over hypotenuse, you would get a positive divided by a positive, which would result in a positive. So we're going to say that sine is going to be positive in quadrant 2. And that's different from what would happen if we had done cosine or if we had done tan. Both of those would produce a negative ratio right there. In quadrant 3, where would we produce a positive ratio? Well, it's a little bit tricky because we have two negatives. So the only way we could create a positive is if we did a negative divided by a negative. And that means that we would have to go opposite and adjacent, and opposite over adjacent would be tan, and that's the only time that tan will be positive in quadrant 3, but sine and cosine will be negative in quadrant 3. So then for quadrant 4, you could probably predict that it's going to be cosine, and if we went adjacent over hypotenuse, yes, a positive divided by a positive, cosine is our positive ratio in quadrant 4. So you've seen that from pre-calc 11 before, and it helps us answer some questions efficiently. And what you may want to look at is you could say, well, if I go through something like this, you'll see these different sort of acronyms, and there's a bunch of different ones. So all students take calculus is a pretty common one that you're going to see right here, and that just means that they're all positive in quadrant 1, sine, S, is positive in quadrant 2, tan is positive in quadrant 3, and cosine is positive in quadrant 4. From time to time, you'll hear me say draw your cast, and that's just me filling those in really, really quickly there. Okay, so now we have some steps to be able to find out a little more detail for some of these questions. Example 1, this is something that you would see still in pre-calc 11, and they want to say, well, find out which quadrant this satisfies. Sine is less than 0, so sine is negative, and tan is positive. So sine is negative in the T and the C quadrant, and that's because it's positive in all of them, and sine's positive right here. And tan is positive. Well, it's positive where they're all positive, and it's also positive where you have our T. So right here, this is the only quadrant that would satisfy this statement. Sine is less than 0, and tan is greater than 0. So we're going to say that in quadrant 3, that would be a true statement. Okay, so you'll see some steps up here to be able to help us find this out in a step-by-step process. So I'll let you take a look at that. You probably want to highlight that, make a note of it, and we're going to refer to that over and over and over again. So starting in this example right here, it says find cosine of theta if cosecant of theta is equal to -3/2 and tan theta is less than 0. So step one is we want to find the angle, and we need to know what quadrant we're in if we're going to find that, if we want to continue on with that. So let's draw our x and y axis, and cosecant is negative. So if cosecant is negative, cosecant pairs up, remember, with the sine ratio. So if cosecant pairs up with the sine ratio and it's negative, then we know we're either in quadrant 3 or quadrant 4. Okay, that's because we have a negative sine value, or in this case, a negative cosecant value. It's telling us that tan is less than 0, so tan is negative as well, and that's going to happen in quadrant 2 and quadrant 4. So it means we know that we are for sure in quadrant 4. So from there, we can draw an angle in quadrant 4. Don't worry about exactly where it is or the proportion of it or anything like that. And we always know that wherever you draw your angle, you draw it perpendicular to the x-axis. And from here, it's telling us that cosecant is -3/2. So we learned earlier that if sine is opposite over hypotenuse, then cosecant, its reciprocal, is going to be hypotenuse over opposite. So from here, our reference angle, our hypotenuse is going to be a 3. And our opposite is going to be a 2. And we could put a negative there to say that it's going down. And based off of that, they're saying find out what cosine would be. So cosine in quadrant 4 is ca adjacent over hypotenuse. And that's tricky because right now we haven't been given the adjacent. So in order to find that, if you have two of the sides of a right angle triangle, you can find out the third side by doing Pythagoras. And if you do that, you'll find that you would get -2 squared plus b squared equals 3 squared. So it would be the square root of 5 right here. Okay, so then based off of that, we could now say that cosine, ca, is going to be adjacent over hypotenuse. So the answer to this question is going to be √5/3. And let's just ask ourselves, is it positive or is it negative? We know that we're in the cosine quadrant. Cosine is positive in quadrant 4. So we've created something in which that's for sure going to be positive. Okay, so that's definitely a challenging example. So what I would do right now is I'd pause the video, I'd work on example B, and I'd work on example C, and I'd see if I could find a final answer. Once you've done that, unpause it and see if it matches up with what we have for B and C right here. Okay, example B, sine is positive. In fact, it's 2/5, so it's either in quadrant 1 or 2. And cosine is negative. It's less than 0. So if it's negative, it's either in the S or the T quadrant. So for sure, we're going to be in quadrant 2. Sine is so opposite over hypotenuse. So opposite to hypotenuse 5. You could do Pythagoras. I'll let you do that on the side there, and you would get the square root of 21. And you could put a negative there if you want, because we're going to the left. And it's saying find the value of cotan theta. So because these reciprocals are so new, we should probably think about this a little bit here. So cotan of theta would be, well, tan is toa opposite over adjacent, so cotan is going to be its reciprocal, adjacent over opposite. Okay, so if we have adjacent over opposite, we would say that that's going to equal negative root 21 over 2. Okay, and then example C. Determine secant, okay, the reciprocal of cosine, if cotan is equal to negative 2 over 3. Well, if cotan is equal to negative 2 over 3, then we know that tan, its cousin, is going to be negative in the S and the C quadrant. But we don't have any more information than that. We don't know if we're in S or if we're in C. So probably you're a little frustrated by doing this question because you didn't know if you're going to be working in quadrant 2 and quadrant 4. And what we have to say is it could be in either of those two quadrants. And so because of that, you're actually going to have a plus or minus answer. You're going to have two potential options. It might be over here or it might be over here. Okay, so based off of that, we know cotan is adjacent over opposite. So 2 is going to be our adjacent value, 3 is our opposite, 2 is our adjacent value, 3 is our opposite. And we can put in our hypotenuse by doing Pythagoras again. And so if you do that on the side, you would have got the square root of 13 and the square root of 13 right there. Okay, so then based off of that, if they want to find out secant, we know that secant is equal to the reciprocal of cosine. So cosine is ka, so this is going to be ha, hypotenuse, over adjacent right there. Okay, so we have our hypotenuse. We could say, let's look in quadrant 2 first. The hypotenuse is root 13, so it'd be root 13 over negative 2 right there. So you could get something that would be root 13 over 2 negative. That would be one good answer. Or if you were in quadrant 4 right here and you did secant hypotenuse over adjacent, you would get positive root 13 over 2. So instead of writing out twice, you could just say it could be negative root 13 over 2 or positive root 13 over 2, and you could just say it's plus or minus. So that's representing both answers right there. Okay, so given the point 2, negative 1 is on the terminal side of angle theta, determine the value of all 6 trig functions. Okay, so this is a good review to see if we understand how each of these reciprocals work. So given that, we could say, okay, 2, negative 1, so we can just estimate where that's going to be. And so that means that we know that this is going to be a distance of 2, this is going to be a distance of negative 1, and if you did Pythagoras right there, you would end up with something where that's going to be the square root of 5. And they want you to find out what sine, cosine, tan, and then each of their cousins, so cosecant, secant, and cotangent. So if you pair them up like that, it's going to be a little bit more efficient when you calculate them. So sine from our reference angle right here would be so opposite over hypotenuse. So if you go right there, you'd have negative 1 over root 5. Cosine would be ka, 2 over root 5. Common question right here is, do you need to rationalize the denominator? It's up to you. If you do that, it's correct. If you don't, it'll be accepted. So there's no need to rationalize the denominator unless it's being asked for. I'm not going to ask for it in this case right here, so we'll just leave it as 2 over root 5. And tan is toa, opposite over adjacent, so we'll say that is negative 1 over 2. And if we want to find out our 3 reciprocals, you don't need to do the question 3 times over again. You can just flip what you had for each of your original 3. So this would be negative root 5. This is going to be root 5 over 2. And this is going to be negative 2 over 1, or just negative 2. Okay, example 4. Determine sine theta and cos theta if theta is an angle in standard position whose terminal side is the graph of 2x plus 5y equals 0, where x is less than or equal to 0. Let's make 2x plus 5y equals 0 look a little bit cleaner. Let's isolate for y and see what would happen if we did that. Okay, so what that does is that actually gives us a line that's going to pass through the origin. It's in the form of y equals mx plus b, but we don't have a y-intercept, or y-intercept has a value of 0. And if you were to graph something like that, -2/5, so rise 2, run 5, we're going to get some sort of line that would look like that. Probably not quite as steep as that. And it's telling us that x is less than or equal to 0. So they want us to find out something in reference to this line, and that means we might be in quadrant 2 or we might be in quadrant 4. But because x is less than or equal to 0, it means that x is going to have a negative value. And on the right side here, x is positive, whereas on the left side here, x is negative. So we can say it's not going to be in quadrant 4 and it must be in quadrant 2. And let's see what our ratio was for our slope. So we're saying here our slope is a rise of 2 for a run of 5. So that means for every 2 units you go up, you went over 5 units to the left. It's probably not my best proportional drawing right there. Okay, so from there, they're saying find the values for sine and cosine. If we want to find out either of these, we need to know what the hypotenuse is. So once again, you should do Pythagoras. So if you do that quickly and you square 2 and 5, you're going to end up with something where that's going to be the square root of 29. And so let's find out what would be sine of theta and what would be cosine of theta. Okay, so think about sine, opposite over hypotenuse, and we're going to get 2 over root 29. And then cosine here is going to be -5 over root 29. So again, you don't need to rationalize the denominator if they're not asking for it, and that can just last as is. Okay. Example 5, I've thought about it. If I feel like this is something we need to come back to, we can take a look at it. But for the time being, let's do an omit. Okay, so don't worry about example number 5. Okay, that's more of a proportional question. Okay, if sine theta equals 2/3, find, well, let's start with this one. Find cosecant of theta. Don't overthink this. If the reciprocal of sine is cosecant, then the reciprocal of sine theta equaling 2/3 would be cosecant theta equaling 3/2. All we have to do there is just take its reciprocal and we're done. That's our final answer right there. Okay, this one's a little bit trickier. Now, in Pre-Calc 11, you may have looked at this a little bit, and they want to know what would be the value of cosine of 90 degrees minus theta. Okay. So let's give just the quick and easy. Let's work backwards here. We're going to give you the answer. So the answer is it's going to equal 2/3. And you're like, why is it 2/3? It's 2/3 because cosine of 90 degrees minus theta is equal to sine theta. These are equal to each other. Okay, now you might wonder why that's the case. So one example of being able to look at it, I don't know if this is going to be the best way to explain it, but if you take some sort of a right angle triangle, and I'm just going to give an arbitrary angle measurement to these. So we're going to say this is 32 degrees. There's our 90-degree angle. So this is going to be 58 degrees. And we're going to label these sides, and we'll label them A, B, and C. So if you wanted to find out what sine of 32 degrees was, it would be equal to A over C. And if you wanted to find out something to do with cosine, now let's do this. This is going to be kind of strange, but let's find out what would be cosine from up top right here, this 58. So from the up top, this 58 right here, so we're not looking around a unit circle or anything like that. From that 58, cosine of 58 degrees would be equal to A over C. They're the same. And what's the relationship between that 32 degrees and that 58 degrees? Well, they add up to 90. And they'll always add up to 90 degrees because using a right-angled triangle, after you have the right angle, the other two angles always add up to 90 degrees. And so then what you could say here is, that means that if you have something like, let's continue on this example, sine of 32 degrees, it would be equal to saying cosine of 90 minus 32 degrees. And now if you get a little bit more general, instead of saying 32, what if we just said, that means that sine theta is going to be equal to cosine of 90 minus theta. And that is a new rule that we can now apply there. Okay, a little bit tricky. Okay, let's do one final example here. We'll take a look at example 7. Okay, find angle theta between 0 and 360 degrees such that sine theta is equal to negative cosine theta. Okay, so we have two different ways that we could take a look at this for sure. I'm going to start with one way, and I'll show you the second way, but the second way we'll probably learn a little bit better after we've done some 6.3 the next class. If you draw your quadrants, this is saying that sine is going to have the opposite positive or negative as cosine right there. And so if sine, for instance, if they're all positive in quadrant 1, then they're not the opposite. So we don't have an answer in quadrant 1. And right here, if we take a look at tan right there, they're both sine and cosine are going to be negative there, so they're not going to be opposites there either. So we're going to have a solution in quadrant 2 and quadrant 4. And this is kind of a strange example. If you draw, you might remember this from last year, if you draw a 45, 45, 90 triangle, you'll know that you would get something here in which you would have sine would be an opposite of 1 over root 2, and here cosine would have a 1 over root 2 ratio as well. The opposite is the same as the adjacent, and so when they're the same, you're going to be able to get something in which they will overlap with each other. Okay, so then based off of that, if they're saying find all the answers from 0 to 360, then, well, that means that we'll have traveled over 90 degrees plus 45. We'll have traveled 135 degrees for that to be true. And I'm guessing a few of you are probably still saying, like, yeah, I lost you there. Why did you just draw that exactly like that? As long as the opposite and the adjacent are the same, then we'll have something where they're going to overlap. And if you were to look at what sine would be positive 1 over root 2, whereas cosine would be negative 1 over root 2, but it's being times by that extra negative, which would make it a positive, and that would make it exactly the same. So 135 degrees is one of our answers. Second answer is going to be over here. And once again, let's make our opposite and our adjacent exactly the same. And sine is going to be opposite over hypotenuse. And that's going to be -1 over root 2. And cosine would be ka, +1 over root 2, times by the negative. It would be exactly the same. They would both be -1 over root 2. So that happens here when you have a reference angle of 45 degrees, which means you would have traveled over the full 360, take away 45, you would have gone 315 degrees. That's a hard question. I'm not sure if we're fully ready for that. I think we'll get better at that with 6.3. So I'm actually going to hold off on showing you the second way to solve for that. If that doesn't sit well with you, then make sure you ask me to go over that a little bit more in class, and I'll do my best to be able to explain that a little bit more, but we'll know more when we learn some 6.3 stuff. Okay, here's your homework right here, and that's the end of the lesson. Thanks. Bye.